Hi, human anatomy and physiology students. Just going to give you a quick rundown of the human skeleton. You'll be going into detail about certain limbs and portions on your own in the future. We've got our little model here in the science building. And so the skeleton is split into two sort of general categories, right? You have what's called the axial skeleton, which is right down the middle. It's the skull, your vertebrae going all the way down, including the rib cage or the thoracic cage, and then ending with your tailbone down here. And then the outer limbs, your arms, your legs, is all referred to as the appendicular skeleton, which is kind of easy to remember if you think of it as your appendages. So the skull you can go into in a lot of detail. There's a whole lot of plates and what we call immovable joints. You're born with a lot of this being very soft, and then it kind of hardens and fuses over time. And then going down the spinal cord here, it has different names for the sections, right? You have basically the cervical plates here, and then it turns into thoracic right next to your thoracic cavity, then the lumbar, and then the sacrum, which is kind of this interesting looking kind of flatter thing with the holes, and then your coccyx, which is a really funny one to spell, C-O-C-C-Y-X. And this model doesn't really show it. This actually usually bends outwards in most people, but this is what you're often breaking if you fall on your butt. You hear a lot of snowboarders and skateboarders breaking their coccyx. And in the rib cage, you just have a number of different ribs. Some people are actually born with an extra rib sometimes, which can lead to a couple different health problems. You have false ribs down here on the bottom too that don't come all the way around. But obviously all of that is to protect the lungs and heart and keep the thoracic cavity functioning. And you're mostly familiar with the appendicular skeleton, right? The outer limbs here, you've got your humerus, this outer bone, and then your radius and ulna. The ulna is always the longer bone that hooks into your elbow here, and then the radius is the smaller one. But the reason it's called radius is because it rotates around as you rotate your wrist, and you can kind of see this in your own arm too. And then the hand is broken down into the carpals, the metacarpals, and the phalanges. They're all numbered 1 through 5, starting with the thumb, 1, 2, 3, 4, 5. Your foot follows a similar structure, as well as just the whole leg. So longest bone in the body is the femur. It has a really awesome ball and socket joint right down here. And then that hooks into the tibia and fibula. The tibia is the big one in the front. That's what you can really feel. This is your shin bone right here. The fibula is this kind of smaller one in the back that hooks into the side of the ankle. The base of this is what gets broken a lot, right? If you break your ankle or anything like that, sometimes the danger is you're also breaking this connective bone down here on the bottom. And the feet are very similar to the hands, but they're usually referred to as tarsals. So these are the tarsals, metatarsals, and again the phalanges. Again, numbered 1 through 5, starting I think with the big toe, moving outwards. Hip bones are kind of interesting. I always find this fascinating that this opening here is kind of one of our little evolutionary struggles because this is the birth canal. So in females, a human head has to fit through there, and so that's often why babies have to be born with kind of softer heads and much smaller before they're fully developed, right? There's a lot of development to do outside the womb because they have to fit through that structure right there. And most of our ape relatives, this opening is actually a lot bigger. That I think it's a consequence of our upright walking that this has become a little bit smaller in the way the skeletons got rearranged. Beyond there's a little bit of anatomy of the bones, which this model doesn't show that well, but basically bones can be made of what's called a cortical bone, which is kind of the really tough outer bone. That's the hard part of every bone. And then there's the trabecular, which is kind of more the spongy bone, which you find on the inside. Most of your outer limbs, the appendicular skeleton, is made out of cortical bone, right? These are meant to be kind of tougher limbs, harder. They're load-bearing, right? Whereas the axial skeleton, the skull, the spinal cord in particular, all the vertebrae, they tend to be more trabecular. They've got more spongy bone. You have your whole nerve column that runs through there. Yeah, I think those are the basic things I wanted to touch on. You can kind of see this floating bone here in your throat. I'm forgetting the name of it now. I think it's called the hyoid bone. That's the only bone that isn't connected to other bone, and again is more protective of your trachea and airways, so those can't be easily blocked. And another shortcoming of this model I'll point out is just that they don't show the detail here, but your clavicle bone here, this is what a lot of athletes are breaking in particular. It hooks into your shoulder blade on the very back. This is what people like to make stick out of their back sometimes. All of this is actually hooked on to the upper part of your humerus here, and again helps with that full rotation of arm movement that we're capable of. This model doesn't show that very well, but you can find things online. So Anyway, that was just a rough introduction. Hope that was helpful. Thanks.